Okay, I have an original effect to share with you today. It's based on something I call the even clusters principle. And I'll add links in the description below to where I talk about this powerful principle, but that's what's driving our effect today. So as you can see, I have a well-shuffled deck of cards. And I think if you stared at this arrangement of the cards for a very long time, you would come to that conclusion. They are well mixed. Okay, so what we're going to do here, which is interesting, is we're going to do everything face up. Okay, so we're going to do everything face up so you can see exactly what's going on. Okay, now we do need 4 roughly equal size piles. It's not essential, but it's kind of helpful. So what I'll do is I'll try to break off about equal size piles. That one's not so equal. Okay, that one's a little better. Okay, these are getting kind of small, but that's okay. So anyway, it's okay if they're different sizes. Now, what we're going to do here is I'm going to, well, start off, we better kind of scramble these here. Now, if you were here, I'd have you cut each of these and complete the cut. Okay, same thing here. Just giving it what's called a Charlier shuffle. And I can add a link in the description below if you want to learn that shuffle. Powerful little shuffle. And then you can come in here and cut the cards randomly and complete the cut. Same thing here. I'll just give it a little Charlier shuffle. There we go. And then you're free to cut it. So you're really kind of deciding what cards come to the top. Okay, so what we're going to do for each of these is we're going to deal each into 2 piles. So left, right, left. Okay, so 2 piles like this. And then we'll keep the piles as pairs. Okay, so these will be like grouped together. Those are together. Same thing here. So just a left, right, like that. So these are little buddies here. That's a pair. Let's see, left, right. And you're watching the cards. That's the key, right? You're seeing the faces of the cards. I don't know if you saw anything sneaky yet, but okay, so we go left, right. And believe it or not, we're done. We're done with the effect, as you'll see. Okay, so quick and easy. Okay, so I have a written prediction off to the side, so why don't we go ahead and just take a look at that. And I want you to think about what could I possibly know about these pairs of cards. Okay, well, this is the prediction. Each pair of piles, so we have 4 pairs, will contain the same number of red cards. Okay, well, that's easy to verify or disprove there. Okay, so how many red cards do we have here? 1, 2, as you can see. And so I'm claiming, amazingly, there'll be exactly 2. 1, 2, 3, 4. Okay, well, I'm sorry to say that's a fail. Okay, 0 out of 4 so far. Okay, what about here? Surely this will work. So 1, 2, 3, 4. I'm sure we have 4 red here, and we may. That'd be great. But we don't. We have 3. Okay, that's a second fail. Oh, golly. Let's see here. 1, 2, 3, 4 red here. Maybe we'll do better here. 4 red, 3 red. Golly, what is going on? We've got to get at least 1 out of 4 correct, and we may. 1, 2, 3, 4. 4 red. I'm hopeful. We'll have 4 red here, too, and we just may, and we don't. We have 2. Okay. I don't know what it is about this prediction here, but what's that? Oh, wait. There is more. But you must flip over the piles first. Why would that help? Flip over the piles first. I'm trying to make some room here. Okay, why would that make any difference? Flip over the piles. Okay, that didn't do anything. Well, let's just look at... Oh, wait a second. Wait a second. So what was that crazy prediction again? Each pair of piles will contain the same number of red cards, but you must flip over the piles first. So 1, 2, 3, 4 red back. 1, 2, 3, 4 red back. How in the world? Okay, how did we do here? Because the faces failed utterly, as you saw. 1, 2, 3. 1, 2, 3. I can't believe it. 2 for 2, guys. Oh, we got a lot of red there. So 1, 2, 3. We're just hoping to high heaven there's 3 here. Oh, there are indeed. And then what about over here? Do we have an equal number of red facing up? 1, 2, 3. And I'm just hoping we have 3 here. We do indeed. Check that out. We absolutely nailed the prediction, despite the very bad situation that we thought we were facing before we turned over the cards. Oh, wow. Okay, wow. So what is this effect all about? Well, as I mentioned, it's about the even clusters principle. And this kind of thing can be used in countless card effects. It truly, truly can. Okay, so how did I do this quickly? So what I have 2 decks. Well, I've taken cards from 2 decks. Okay, so what I've done here is the red back cards are clubs and hearts. Okay, that's what those are. These are all those are all clubs there. And then the blue back are spades and diamonds. Okay, so that's the first thing. So just pull out, okay, why don't we just separate them here? Okay, so we have red, red, oh, red. Okay, so that's where you begin. So clubs and hearts, red back, spades and diamonds, blue back. Okay, so that's all I did. Now, just think about the name I gave this principle. I call it the even clusters, like groupings, principle. So what's the even referring to? Well, it's referring to the fact that blocks of cards of interest are found in even-sized groups. That's all it means. Well, if cards are found in even-sized groups, what does that guarantee will happen when you deal the cards into a left and right pile? Well, with a little bit of thought, you'll realize that each of those piles will have to have the same number of cards from those even clusters that you set up. Okay? So all I did here was, and then sometimes you have to kind of tweak things. Maybe I'll do one there. I'm going to put all of the red back cards in even clusters. And you can do it with blue too, but we have to make sure that the red cards are in even sized groups. There's 4. Then we have 1, 2, 3. You can do 4, 5 if you want. Now, you can have the blue in even sized clusters or not. The key is we're focusing our attention on the red back decks, red back cards. 1, 2, 3, 4. And then 1, 2, 3 maybe, and then 2, and then 1. So I'm intentionally putting the blue back cards in odd size groups, but you don't have to. And then we'll do that. And then this. Okay, and then this, and then, okay, and I'll drop those there. Okay, so let's just take a look. So that's the kind of thing I did. Just took me a couple of minutes. So what I'm checking for here, what's essential is the red back cards have to be in groups of 2, 4, 6, 8, even size clusters. We really don't care so much about the blue back. Now, if those all happen to be in even size clusters as well, then that would mean that you would not only match the number of red back cards in these 2 piles at the end, but also the number of blue back cards. Okay, but it's kind of nice to not have those matched, so that's why most of them are odd for the blue back cards. Okay, so that's the kind of thing I did, and then all I did from there is I just took a look at the front and checked to see if maybe I need to do some adjusting. Okay, so for example, this isn't too great right here. Do you see that? That's not the best because of the, big cluster here of red faces and black faces. Okay, so let's just take a look at kind of what's going on here. Okay, so what we want to do is, these are all black, is we want to move some of these like over here somewhere. In fact, that may actually do it. So the idea is you don't want to disturb. See, maybe I'll move two of them over here. You don't want to disturb the essential characteristic that we just showed. Okay, so that's not too bad. So let's just check this to make sure that we have retained the property for the backs. Namely, we just need the red back cards to be in even clusters. Okay, so you can see we have kind of one violation right here. We have 3, so I'll just move that one. So now we have 2. 1, 2, 3, 4. 1, 2, 3, 4 for red. Just focusing on the red. 4, 2, 4, 2. Okay. So as far as the property goes, this even clusters principle, this is going to work out for us. And I think that's pretty good. Okay. So it may take just a little bit of adjustment. The key is you want the backs that are red in even size groups, but then when you spread the cards, it would be nice for these to look kind of random as far as the color distribution, which is what I had at the beginning, if you look at it. Okay, and then we're set to go. And then you just do everything that I did. Now the key is here, you just cut off anywhere at a spade or a diamond. That's kind of like our dividing. So there's a diamond. Because what that will do is it'll guarantee that you don't break up any of the red back pairs or even clusters. Okay, and then from here, each of these can be Charlier shuffled, which is really just a packet cut. That's all it is. Same thing here, because we're going to deal out into 2 piles. So dealing out into 2 piles will not change the fact that these were found in even clusters, as long as you view it as kind of going around corners, which we would. Okay, and you can cut it anywhere. Okay, so maybe we'll just do this one here. Okay, just to kind of show you, so we don't redo the whole thing. And then you can just deal these out into 2 piles like this, and we'll just pray to heaven that I haven't made a mistake on this particular packet, since I'm kind of rushing here. And then of course, it's not likely. I mean, it can happen. So 1, 2, 3, 4, 5. 1, 2, 3, 4. 4 red, 5 red. Okay, so it kind of failed there. But hopefully, if I haven't made a mistake in setting it up or in left-right dealing, there should be an equal number of red back cards. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we nailed it. So anyway, that's the secret. But the idea here is something that's so versatile. You can use it in so many ways. And I've used it in several ways. So take a look at the videos in the description, because you'll see completely different applications of this powerful principle. So thank you for watching, and take a look at other videos on the Absolute Math Magic channel.